This is the second part of the lecture 2, which is going to describe the economic evaluation of the process design in the context of the capital cost and the operation cost. So we had been looking at the cost estimations. So last week you have been looking at how to estimate capital cost. We are continuing the estimation of capital cost today. So the first thing we needed to look at is the cost estimation by considering the buying power or the time value of the money. So the buying power of the $1 change with the time. So for example, the cost of the buying your mobile phone in 3 years ago is not going to be the same today. If you're looking at the Chinese black bean noodle, that 10 years ago it was the 5,000 won. Now the same thing, we needed to pay say 6,000 won for buying the black noodle. So the buying power of the same money change with the time. So we needed to take into account the variation of the value of the money for capital costing. So the cost of the process equipment, reactor, maybe heat exchanger, distillation column, whatever, is subject to change of the based on the time. So in order to take into account inflation or the value of the time for the capital costing, we typically are using some index. So the Marshall and Swift index or chemical engineering plant index. So the slide shows that the Marshall and Swift index. So there are 3 lines. One is the related with the chemicals, and the other one is the process industry, typical process industry, and the green one is related with petroleum product related industry. So based on the particular year, then we can have some index. For example, in 2000s, for the green one, related with the refinery and the petroleum products process, now we have a roughly 1,150. Okay, so then in 2000, let's say 8, for the green one, we have the say 1,750. So based on 2 difference, we can quantify the difference in the cost of the capital costing method. So some cost is maybe based on the particular year 2000. Some cost is made based on the 1906. Then we want to take into account the cost based on the 2008. Then this is the way we can update cost based on the cost index. So let's say I want to calculate the cost based on 2008. Then I have cost based on the 2000. Now I need to take the cost based on the Marshall and Sharp index here. So that will be 1150. Then the year X. So that is 2008. Then we have the index, let's say 1750. Then cost might be $1 million. Then we have the updated cost based on the difference between 1750 against 1150. So this is the way to estimate cost. So another example, let's say this is the reactor, okay? Then this is followed by the separator. So I look at the books, say the book A, then I found this is cost is 2 million. Then I look at the journal paper. I found that this is the cost for 5 million. Okay, then the capex of this process between the reactor and the separator can be 7. Okay, $1 million. So we cannot say that because we need to take into account the evaluation is made for the costing for reactor and the separator. So this might be costing is made maybe say year 2000. Okay. So this journal paper from this reference, the $5 million is cost at the year 2004. So the 2 million is not the same of the 5 million at the 2004 compared to 2000. So then we need to take into account the difference in the time of the year for the evaluation in the capital costing. And second, then I want to take into account the overall capex today, like 2020. What is the cost for 2020? Then this is the why we needed to use index. So if I want to have the common basis of the estimation for the capex based on the particular year, then I can update cost from 2002, 2020, 2004 to 2020 using the index. So let's say reactor cost is 2 million, then multiply with index, okay, at the 2000, then index multiply with 2020. Then the separator, the $5 million, then the index will be 2004, and the index will be 2020. Then I have the capex, capital cost, based on 2020. Okay. How do you get this number? If you want to use the like Marshall and Shaft index, you can use this reference or this graph. Then if you want to look at the other index, for example, chemical engineering plant cost index, you can use it, okay? These number. So I'd rather say the most of people in the process industry are using this chemical engineering plant cost index. It doesn't mean other factors like Marshall and Swift index or Nelson-Farrar refinery constraint index are not used. They are using in the industry, but the most common thing used in the industry is the chemical engineering plant cost index. Okay. So this is based on the index per year. So 1987, the chemical engineering plant cost index is 324. The next year, 343. So this is the year average value for the index. But then if you're looking at some reference, then some database, you might have the index based on per month, okay? In January of 1983 and February of 1983, then you have different the index. You can find these index from the chemical engineering magazine or some costing-based database. If you are not sure about such detailed database, you can use the year average number, okay? It's not going to be proportionally increased or continuously increased based on the change of the year. So if you're looking at the index, some years up and some years down, okay? And some years up and some years down, okay? Here. So it depends on the engineering community, plant engineering community and the plant industry. Some years there are a lot of the plant project, but some years not. And depending on the boom of the project, or depending on the progress of the number of projects in the industry, the plant index may be increase or decrease. It is also depends on the market condition, like the oil price, okay? So then the plant cost index are dependent on the such the marketing, the atmosphere. So based on the cost index, we can update cost from B year to A year. Next section is about the estimation of cost for the production. There are two elements related with direct production cost. There are indirect production cost and there are direct production cost. So there are two major categories related with operation cost or production cost. Then the direct cost can be divided into the two. First one is the fixed operating cost and the variable operating cost. Variable means the costing is dependent on the amount of the product produced. So for example, the amount of the product is depends on the amount of the raw materials are used. So if the raw materials to be used in the industry are increased, then we can expect the amount of product are going to be increased. So if we want to produce more, then we needed to provide more utilities. Utility means in the industry here, in the chemical industry or refinery industry, means utility means the water or the steam or electricity. So there are different things to be used as a utility, but then the water, steam, electricity are the supporting heating medium or cooling medium used in the process industry. So the amount of the utility to be used by industry depends on the amount of the product and amount of the raw material to be used. So consequently, if the amount of product produced is increased, then the utility consumptions accordingly is to be increased. So there are some kind of the proportional relationship between the amount of product and some operation cost. These categories are related with variable operation cost. On the other hand, costs sometimes do not change with the production rates. You have more or less the fixed cost regardless of the size of the production or the amount of product to be produced. Like, for example, the maintenance, including labor and the materials, and the operating labor, we need some people to work on the production. Slight change in the amount of production is not going to be changed in terms of the human power, manpower required by the process. Laboratory cost, it's R&D related things, then some cost should be paid. It's not heavily dependent on the amount of the product to be produced. Supervision, then the plant overhead, and the capital charge, tax, insurance, license fee, and the loyalty. Capital charge means you needed to pay back some interest or some money related with your financial arrangement when you have borrowed the money from the bank. Then the project in the chemical industry is heavily capital intensive investment required. So then you probably needed to borrow the money from the bank. Then there are some charge related with your borrowing the money from the bank. That is probably it's not heavily dependent on the amount of product produced. So that is one of the items for fixed operation cost. Tax, yes, based on your sale, then you have a different profit. Then you probably say as the tax might be dependent on the amount of product. but there are some element which is not heavily dependent on the amount of product and the sale of the product. So they're like you have some people work on the project, you have some equipment built for the project. There are some other tax element related with other non-product related things in the industry. So that's why the tax are not dependent heavily on the amount of product produced. So that is another item related with fixed operation cost. Insurance and the license fees and royalty. So in the chemical industry, you may need to buy the license process. So like ExxonMobil, maybe Shell, okay, they own some intellectual property for producing certain product. Then you have to buy the intellectual property of producing a certain product or some process, a flow sheet or some process system. That is the additional money to be paid to the owner of the intellectual property. That is called the license fee or royalty. Okay, so that is also the element of the fixed operation cost. There are second production cost is categorized as indirect element. So there are some cost, production or operation costs indirectly incurred. So some general overhead, maybe R&D development cost, and the sales expense, or maybe you might keeping some money for the future. These are related with some indirect activity of your production. This called as indirect operation cost, indirect production cost. This is typically about 20 to 30% compared to direct production cost for the site. Then how do we estimate operation cost or the production cost? The table shows some factors for using the estimation of the manufacturing cost or production cost. Maybe. So in this table, the head of this table is given as the manufacturing cost, but that is another expression for the production cost and the operation cost. Okay, this is one example. This is not the only one you need to look up. This is one of the examples you can refer. So you have some indication or you have some illustration how we can estimate the cost for the production. For this table, you may not have all the information in detail because I just take the copy of the one part of the table for the illustration purpose. So full details can be found from the reference given on the left and bottoms in your slide. So if you want to see more details on the equation involved in this table, you can look up the book, okay? So there are different elements than for the operation cost. Then some people may have different categories. In the previous case, we categorize it into direct against the indirect. Then the direct one is further divided into two sub-items. One is fixed one and the variable one. But on this table, it is based on slightly different definitions. For example, sum of cost related with direct element. Some cost is referred as the fixed element. Some costs are categorized as the general expense. So what I'm trying to say here from this example is some people may have a different definition for sub-items of the operation cost. Okay? But if you're looking at item by item, you can see that all the elements covered in the previous slide, like this one, will be given in this table. But in terms of the categorization of the sub-items under the category of the production cost are simply different. But it doesn't mean this is wrong. This is just different way of the estimation of the operation cost, okay? So on the table, you can see that is some of the factors, okay? So people are typically using some factor, then using this factor, then multiply with some numbers, then we can estimate some cost, okay? So this is just the example, okay? You can use this one like if you want to estimate like operating supply, then you can use the 0.009 multiplied with FCI. FCI is not given here, but FCI means fixed capital investment, okay? Fixed capital investment. So if you have the capital investment cost, then you can use the 0.9% of the factor for estimating operating supplies. So what about this just factor CRM? Raw materials. So raw materials, you need to buy the raw material based on the certain cost. When you are purchasing raw material, you probably have the contract with your supplier, and you probably agree with some cost. So that can be used, okay? That is the meaning. Utility, then that should be calculated. That should be based on the agreement with your supplier. If you're getting electricity from the electricity supplier, then you probably have the unit cost. If you want to produce your electricity on your side, then you have the cost incurred for producing electricity on the side. Then you can calculate the unit cost of the electricity. So this one should be found, or you have to determine, or you have to define. So some other things can be estimated from some other factors or some other cost. So based on these costs, we have some estimation. Like operating labor, so we have the cost of a COL. So any numbers not given for this one, which means we needed to define what we needed to calculate the operating labor cost. So for example, say you have one factory, then per factory we needed to use the 50 labor or papers or operator, then you have unit cost for people to be hired for your company, then you can estimate the operating labor cost. So if COL is given, then you can estimate supervisor cost and the clerical labor cost. So 80% more based on the operating labor cost will be direct supervision and the clerical labor cost, okay? So we have some interconnection between the cost against another cost, okay? So by looking at this relationship, we have the overall manufacturing cost, overall production cost based on this formula, okay? So this is one example how we can add up the cost, okay, for the operations. So you do not need to remember these things, because when you want to calculate cost, what you need to do is to find this information and apply them for your case. So case by case or the process by process, you might have a different the definition for the costing. Then you might have a different definition of the methodology of the operation cost estimation. So it's a very case specific, okay? So you should be in control how you need to define the problem for the cost estimation, how you want to apply the costing methodology, okay? So as an engineer, you need to understand the methodology of costing. Otherwise, you may not have the full confidence in your cost, okay? One of the major elements related with operation cost is raw material cost. So this is the largest individual cost and the big influence on the process economics. So prices can be changed significantly because the market changes with the time. So for example, the refinery company need to process the crude oil in order to produce some petrochemical feedstock. Okay, there are many refineries in the Korea, so like SK Energy, GS Caltex, and the Hyundai Oil Bank. These are the example of the refining company. They needed to buy the crude oil from the different parts of the world, maybe from Saudi Arabia, maybe Venezuela, okay, maybe Arab Emirates. Then so the oil price change sometimes very quickly. The price change might be too volatile to be estimated. So the oil price of the last year is not same the price of today, and especially in this circumstance, the oil price is going down at the moment. Then based on the oil price, the sale price of the product in a refinery will be totally different. The price is very different, okay, for the raw materials. Then also price of the raw material depends on the contractual arrangement with the supplier. Especially in the petrochemical industry, the buyer have a long-term contract with the supplier in order to have the security of the raw material for long term. So in a chemical industry, sorry, in a refinery industry, you're going to operate, say, 2 years, 3 years without breakdown or without the stopping. So if you want to operate the refinery for 1.5 years, then you need to have the supply of the crude oil for next 1.5 years without any problem. Okay, so typically they have a long-term contract. It will take a while to have the crude oil from the Saudi Arabia or Arab Emirates to, the Korea. So it is quite common to have a long-term contractual arrangement. Okay, that means we may not be able to change the cost of the price of the raw material. 2 years back, the cost might be different with the cost now, but we had a contract 2 years ago that we cannot change the cost now, okay? It might be good, it might be bad in terms of the economic circumstance. So it's very difficult to estimate price or forecast the price of the raw material, especially in the petrochemical industry, okay? So there are one thing to be remembered in terms of raw material cost further given in this slide, because let's say this is a reactor, then we need to produce, say, 1 ton per second of the product of the P. Then we need 2 tons per sec of the feed required in order to produce 1 ton of the product. But then if this is the batch process, then the productivity depends on the how you want to operate your plant. But in a continuous process, you're probably operating 1 year, 2 years without stopping. Okay. Then this is probably fixed. In a steady state operation, is not going to be changed. So that means the amount of the feed to be used by this process is more or less fixed. So 2 tons is required to produce 1 ton of the product. That is going to be the constant for next 12 months or 2 years. Although the feed raw material cost is the largest element in the costing for the operation, we may not have a degree of freedom to change for this one. Okay. Also, we may have long-term contractual arrangement, so the cost might be fixed. Okay. So we may not have a degree of freedom to manipulate it. So what should I do in terms of the reducing this cost in a state operations? For 1 year, without stopping, we are running the continuous process. Then what we can do is to improve the process through the debottlenecking. So in the chapter 1, we discussed the possibility of taking debottlenecking in the process industry. So after 1 year, we needed to improve it for somehow in the, let's say, in the catalyst and the reactor, or maybe design of the reactor. Then if we reduce the 2 ton to say 1.8 ton from next year operation, then we can reduce the cost. But for the until that debottlenecking is happen, we may not be able to manipulate the amount of feed to be used in this process, and we may not have the opportunity to reduce the cost related with raw material. Okay? So that is some limitations of reducing raw material cost, although that is the biggest element in operation cost. The second thing related with the operation cost is utility cost. So raw material cost, after the raw material cost, utility cost, probably the most important operating cost. Okay. So in the previous slide, I explained we can reduce cost related with raw materials, but we may not be able to reduce it because of the constraint imposed in the process, especially for steady-state continuous operation. So you both might be interested in the reducing the operation cost. Why? Can you reduce the capital cost? Can you reduce the capital cost? In the beginning, before starting your project, we can reduce the capital cost. But once the production plant had been built, once the process starts operating, then we do not have the opportunity to reduce the capex, capital cost. Then we probably need to look at the opportunity for reducing operation cost. Okay. Then how can you reduce the operation cost? We needed to first look at the largest costing element for the operation cost. That was raw material cost. But we may not be flexible for the steady state continuous operation. So then we needed to look at second largest element in the OPEX operation cost, that is utility cost. So minimizing cost for utility had been the main activity, key activity for process engineers working in operation company. So utility include the fuel, electricity, steam, cooling water, and refrigeration, air, inert gas, etc. Okay. So fuel, electricity, steam, cooling water, refrigeration are related with energy. For example, fuel is the heating medium in order to provide the energy into the process. Steam is the typical heating medium for providing heat to the process. The electricity, either a way of the providing heat to the process or way of the providing the electric energy in terms of the providing shaft work. Like if you want to drive the pump, if you want to drive the compressor, then electricity might be used, okay? Cooling water is the cooling, the medium for reduce the temperature or removing heat from the process. Refrigeration is the system where the heat is to be removed by the refrigerant cycle. Okay, ambient temperature, we are using cooling water. In a very low temperature, the refrigeration will be used. Compressed air might be used for the instrumentation and control and maybe some equipment maintenance. Then inert gas might be used for reducing some safety problem and for like a reaction. Then the non flammable and the non-reactive gases may be used in order to reduce temperature, maybe reduce the pressure of the reactor and the separator. Then inert gas might be used, okay? Then the cost depends on the significantly of the fuel used, and also the cost of utility fluctuated with time, and also the utility cost strongly depends on the contractual arrangement with the supplier. Okay, so the final one, like if you want to use electricity, then you don't want to produce electricity on your side. You probably have the contract with Hanjun, okay, national the electricity supplier. Then you probably have the contract arrangement such that the maximum power you can use per day from your side is say 50 megawatt. Then if you are having 1 extra megawatt, the service charge will be increased by 20%, something like that, okay? If you want to use 20% more the electricity in summer, then you will pay 50% more cost on purchasing of electricity, something like that, okay? You have certain contractual agreement with a price related with supply of the electricity. So the cost is going to be changed based on the type of the fuel used for producing the utility. So that will be explained with this example, okay? What should I do? The first thing is say we have the reactors. So there are feed kept in the storage tank. That is kept at the, let's say, 20 degrees C. Then we need to have the pump to supply this feedstock into the reactor. This reactor is operated at 200 degrees C. So what shall I do here? I probably need to have heat exchanger using, let's say, steam. Okay, so I needed to increase temperature from 20 to 200. How can I increase this temperature? That is typically done by heat exchanger in a process industry. So in a heat exchanger, in a simple diagram, one stream here is 20 and then turn that into 200. So we needed to provide heat, okay, from somewhere. How can you provide the heat? That might be done by steam. Okay, steam is used, then the heat is transferred from steam to process stream, then the temperature of the stream is to increase from 20 to 200. Okay, so can I use the electricity? In your home, the heating might be done with electricity, okay, rather than using steam. So of course, we might have the facility to provide electricity in order to provide heating. But in the process industry, steam is common. The reason for using steam in the industry will be explained later. But then let's say you select the steam, okay? You select the steam to provide heat. So then question is, how can you make a steam? How can you make a steam in the process industry? In the steam, if you want to boil the water in your house, it's not a big deal. But in the process industry, we need some heating device to increase the pressure of the water and then turn that into steam. So that is typically done with the so-called boiler. So we're burning the fuel to the boiler, then through the boiler we have the water, then we have the steam. Okay, then steam is produced from the boiler, then that is used here. Okay, what happened to this steam used in the heat exchanger? It becomes typically condensate. So the high pressure steam releases heat to the process, then after losing the heat, then it becomes the water condensate, hot water condensate, okay? Then it is returned to the boiler, then mixed with fresh water, then turn that into steam again. That is a common, okay? Why steam is used in the industry compared to electricity? Steam is cheaper, okay? So we can illustrate by this reactor for the preheating using the steam. Then steam is used, produced from boiler. So in the boiler, we burn the fuel. So what kind of fuel we can use? We can burn the oil. We can burn the coal. We can burn the biomass, okay, whatever. Then we can use a different type of the fuel in order to produce steam from the water. The function of the boiler is to get the heat from the combustion of the fuel and turn water into steam. In terms of the producing steam is the same. Then we need a certain amount of the Q from fuel, but we may use different types of the fuel for production of the steam. So different fuels have different costs, okay? Then, although we have the same steam here, let's say steam, we are using 10 tons of the steam per hour for this functioning, then the amount of fuel used by oil will be different with the coal. The amount of biomass to be used in the boiler might be different with oil or coal. So the cost of the steam is different based on the fuel used. So that's why we have different costs based on the choice of the fuel. Okay? The costs can be very different based on the fuel used. Okay? So price fluctuates with the time. Let's say the electricity might be used, not the steam, for the heating. Okay, so in Korea, the price of electricity between the day against the night is not different in your home. Okay, so but some other country, the cost might be different between the day and the night. Okay, some country may have different cost, summer against winter. Okay, so when you're using electricity, you have a different cost tariff. Then you have a different expense, although amount to Q is the same. Okay. The second thing is, you are using the same electricity, then you have the contract with a supplier. They might be charging you the different cost. The summer cost might be different with the winter cost. Then also there are some different costing per the amount of heat is used. So that is unit cost, and based on the use of the amount of the amount of the power P used, then you have a different unit cost. In the beginning, the unit cost is just low. In the middle, then you have an increase. If you are using too much, the unit cost of the electricity is very expensive. Okay. So different fuels have a different cost. So that should be taken into account. Then that is why it's not easy to consider estimation of utility cost. Okay. Here we have maybe different cases. So in the previous case, in the storage tank, that was 20. Then we need to increase the temperature to the reactor using steam. So then that was temperature was 200. Okay. Then steam is used. But some reactor may be required at say 500 degrees C. Okay. Then the steam is not used. Steam may be, depending on how you have the engineering margin in your design, but steam is typically used so below 300 or 350. Okay, so in other words, more than 350 or 300 degrees C, heating is not efficient if you want to use steam. Okay, using steam for the heating higher than 350 is not favored. Okay, so then we want to change that into 20 degrees C to 500. So then what shall I do? How can you make this steam? We burn the fuel, then providing heat from turning from water to steam. And that is the so-called boiler. But we can have a boiler here. But rather than using steam, then this pipe goes through this boiler. This arrangement, this facility is called a furnace rather than furnace. When this combustion unit is used for producing steam, people call it boiler. Okay? When combustion device is used to produce steam, then this device is often called as boiler. Okay? If the combustion unit is used for providing directly heat to the process, we typically call the furnace. Okay? Now we burn the fuel here. Okay? We burn the fuel. is the same. But in the boiler, the steam is produced from the water. But here, we are using fuel to provide heat directly for the process steam. So in some case, the temperature is higher than 500, okay? Then, we burning the fuel here, we burning the fuel here, but the use of the energy is different. Steam is indirect or secondary heating medium for the process, and here fuel is used directly for producing, so providing the heat for the process, okay? So utility include steam and the fuels, and electricity are used for providing the heat. The way of using fuel and steam are slightly different, okay? Fuel might be directly used in a furnace. Fuel might be used in order to providing steam, and steam is used then for providing heat, okay? What about the cooling water and the refrigeration? That we are typically say cold utility, okay? So fuel and the electric steam is related with hot utility. So these are related with providing heat. These are related with providing cold. So providing cold energy in the industry means taking out the heat from the process. So cooling water is used for taking out heat, and refrigeration is used for taking out heat. What else? What other cooling medium is used in the industry? It's not given here. Another one is the air cooling. Okay, so the cooling water is used when water is around, but in some part in the world, like the desert, then you may not have the supply of the water, then air cooling might be used. And also the water, the pollution might be the issue, then air cooling is used. So the air cooling water is based on the temperature, ambient temperature cooling. But if the temperature is very low, then we have to use refrigeration, okay? So how we can provide water, cooling water, refrigeration, air cooling will be discussed later, not today, okay? So we're going to look at this steam, but it'll take a time to explain all the detail of this steam. So probably I needed to stop the lecture at this point and discuss further things in next sessions, okay? So today, we have been looking at the example for estimating the capital cost using some factors, and also the power law, and also the chemical engineering plant index. After we're looking at the example for the capital costing estimation, we move into the next session where the production or operation cost can be estimated. We may need to define the cost. We may need to use some factor to correlate the cost from the other cost element. Then the biggest element of the costing for operation cost is first the raw material cost, and second is utility cost. So utility cost estimation is complex because of the complex nature in the provision of the heat or cooling. But how we can provide the heating and cooling in the process industry, that will be discussed in more detail, including the estimation of such cost in the next session. Okay, thank you. I needed to explain one more thing further. In the previous case, the reactor is given with preheater here. So preheating was made, for example, with the steam. Then let's say this is a 200 degrees C, then we need a separator here. Then we might need to separate at the 70 degrees C. Then we need some cooling, okay? So we need some cooling. So that is typically done by heat exchanger. So the cooling is done by, as I said, it might be done by cooling water. It might be done by air cooling. Okay? If this temperature is not the 70, let's say if this temperature is minus 20, then the cooling water and the air cooling cannot be used. Then we need to use refrigeration, okay? For this sub-ambient cooling, we need refrigeration. So these three are the typical cooling medium for the industry. So above the ambient temperature, we might need to use cooling water and the air. Then under the sub-ambient condition, we probably need to use refrigeration, okay?